Good morning. Today we're going to start our discussion on Chapter 2, Section 1 of your textbook. The main idea for today is you can use motion diagrams to show how an object's position changes over time. So one of the terms for today is going to be motion diagrams. And the essential questions are, how do motion diagrams represent motion? And also, how can you use a particle model to represent a moving object? By the end of this lesson, you should be able to answer both of those in your own words. Actually, at the end of the notes, it's going to ask you to answer those questions. So before we get started, think about different types of motion that you have encountered, different types of motion that you have witnessed. And just go ahead and write down a few examples here. What types of motion exist? Some things may be, as far as motion that you witness, is an object moving in a straight line. You can have straight line motion. You can have things that are moving in a circle. All right, you can have things that are speeding up. You can see motion where things are slowing down. Okay, and you can continue with your list. What types of motions have you witnessed? All right, so what is motion? What is the definition of motion? Okay, motion is the action of changing place or position. The action of changing place or position. So how do you know if that is taking place? Take a look here. Take a look at where my pen is. Now close your eyes. Close your eyes, no cheating. Keep them closed. Now open your eyes. Has my pen moved? Yes, it has moved. So how can you tell that it has moved? So what you're doing is you are using what is around it, okay, its background, to determine whether or not it's moved. Before, it was here. So looking at this, you're using different things as reference points. You may have been using where it was aligned as far as its number, or how it was aligned to this line. Okay, so you can see that it's closer there. Here, it's a lot further away, so it's not as close to this line or this number or whatever you're using as your reference point. Okay, so how can you tell if something is in motion? It's by using the background, or by comparing its location to its background. So what this means is that you're using some type of frame of reference to determine if an object is moving. So what is a frame of reference? A frame of reference is a coordinate system for specifying the precise location of objects in space. Frame of reference is a coordinate system for specifying the precise location of objects in space. All right, so where is it located, and whether or not it moves depends on how its location changes based on that reference point. And that means, as far as motion, it can be subjective, all right? Or rather, it's dependent on what the reference point is. So for example, a train comes down the track. If you are the reference point, so using yourself as the reference point, and you are standing near the track, is the train moving? So train is coming down the track. I am standing near the track, okay? And the train is coming down the track. I am the reference point. So based on using me or using yourself as the reference point, you're standing outside, okay, next to the track. Would the train be moving? So the answer would be yes. Why? Because as far as its location, based on where you are, okay, you being the frame of reference, it would be moving, all right? It's getting closer to you, okay, and then it's passing you. Okay, distance gets shorter, and then distance increases away from you, okay, in the opposite direction. All right, so that would be yes, the train is moving. So its position is changing relative to myself or yourself. All right. Now, next question. If you are the reference point, so you're still the reference point, and you are sitting on a seat on the train, is the train moving? Yes or no? If you are the reference point, then according to the reference point, okay, the location of the train is not changing, all right? If I'm sitting in a seat on the train, then what happens is I am moving. So I'm sitting on the train. The train is, okay, moving if you're looking at a reference point. So let's say train, you see mountains behind me. So what happens is, all right, you can see according to the background here that the train is moving, but I'm not using the background as the reference point. The reference or frame of reference is the person that is sitting on the train. So what happens is as that train moves, that person moves along with it. Their position relative to each other is not moving. So based on the reference point, the train is not in motion. Okay, the train is not moving. So since the reference point, say the distance between the reference points, I keep saying the reference point, the frame of reference however you want to say it. Which is in this case myself sitting on a train, and the train. The distance between the frame of reference and the train does not change. But again, that motion is going to be dependent on what you're using as the frame of reference. So even though I'm sitting on the train, if I'm the frame of reference, no, the train is not moving. But if I am looking out the window, okay, and I am looking at how the scenery is changing, then I'm using the background, okay, or the environment, what's external to the train, as the frame of reference. And then the train, yes, it would be in motion. Okay, let me switch screens. Let me stop sharing, just to make sure that I'm sharing the right screen. Okay, so you should see a slide. So as far as motion, all kinds of motion, when an object is in motion, its position is changing. Its position can change in many ways, including, so these are just some examples of types of motion. It could be moving in a straight line, could be moving in a circle, could be moving in a back and forth vibration, such as in a pendulum. So a description of motion relates to a place and a time, all right? Okay, on the back of your notes, you have several terms. Or page 2 of what you have. So we have a model. What is a model? A model is a representation of a person, thing, or proposed structure so something like a model train, or you can draw or make a 3D model of an atom, all right? So they're representing something. Now, there are ways of representing motion that we are going to be talking about, right? So one is the motion diagram. And a motion diagram is a model of motion which consists of a series of images showing the position of an object at equal time intervals. Okay, so for example, grab your book. This is in chapter 2. Right, if we're looking at these images right here. All right, these are pictures that are taken of a person that is running. But what they are taken at very specific time intervals. It could be a picture is taken every second on the second. So this might be at 1 second, this could be at 2 seconds, this could be at 3 seconds. So as far as your pictures, they are taken at regular time intervals. Then what happens is if you overlap them, you get this. All right, so this is an example of a motion diagram. And what happens is now that you've overlapped them, you can see what's happening as far as this person's speed, get an idea of what's going on. Are they speeding up? Are they slowing down? Are they keeping a constant speed? Running at a regular, like cruise control on a car, okay, would be a constant speed. The way you can see is that if you notice, there's a dot down here for each frame, all right, the motion. And if they are equally spaced, that means that their speed is constant. Again, cruise control, all right? So this person would be moving at constant speed. So what this is this is a motion diagram. The next term you have on your paper is talking about a particle model. This is a type of motion diagram, but what happens is rather than having images of the actual object, you have dots to represent that object. Okay, so that would be a particle model. It is a type of motion diagram that uses dots to represent the object that you are focused on. So a particle model is a simplified version of a motion diagram. In which the object in motion is replaced by a series of dots. Sorry, here you go. Now remember that as far as when these pictures are taken, the unit of time has to be a specific interval, a consistent interval. You can't take a picture at 1 second, then at 2 seconds, and then another one, the next one will be at 5 seconds. It's got to be every second, or you can do every 2 seconds or every 3 seconds. It doesn't matter as long as the time interval is the same. So going back here. So motion diagram and particle models, a series of images showing the positions of a moving object at equal time intervals is called a motion diagram. All right, so this would be a motion diagram. Particle model is you replace the object or objects of interest with single points.
Consider an example of straight line motion. A runner running in a straight line. One way of representing the motion of the runner is to create a series of images showing her different positions at equal time intervals. Notice that the runner is in a different position in each image, but everything in the background remains in the same position. This means that relative to the ground, only the runner is in motion. A series of images showing the positions of the runner at equal time intervals is called a motion diagram. A particle model is a simplified version of a motion diagram in which the runner in motion is replaced by a series of single points. The size of the object must be much less than the distance it moves. If you see the bottom part of the animation, it shows the particle model for the runner's motion. You can see that applying the particle model produces a simplified version of the motion diagram.
All right, in order to finish up these notes, what you need to do is now go back and revisit the essential questions All right, so first question, number one, how do motion diagrams represent motion? And number two, how can you use a particle model to represent a moving object? Okay, so you are going to go through your notes, read the text, and answer these questions. Be thorough with your answers.